from this computer. Okay, thanks. Okay. So yeah, you said the petrographic analyzer you had questions about?
Yes. Yeah,
Okay.
that.
Yeah.
Like recently, I was helping our sedimentary geologists take pictures of sediment or the grains of rocks. And it's
Mhm.
like, oh, let's put this on just to see what happens. And we got a blue picture with like glowy pink spots all over it. And it's like, oh, is this fluorescence? And then can I use this to photograph other things that I know fluoresce?
Oh, sure. So can I just ask, are you so the petrographic analyzer and the fluorescence kit are two separate things.
Okay.
Yeah. So were you trying to combine them or are
Well,
you
there's those
these
black.
here?
Yes, those.
Okay.
Yes.
Okay, perfect. Yes. So this is the fluorescence kit. And
Okay.
just so you know, in case like you need an aid in the manual that you have, I think so on page so this will just kind of help you when you actually set it up, but there is a spot in here. Um yeah, so it's page 36, and 36 will show you how to configure the
Okay.
fluorescence kit. Yep. So couple of things is what happens when using the fluorescence filters is you'll mount these directly over top of the flash heads, which I believe you've done,
Yeah.
right? Okay. So what that will do is emit light at the 505 nanometer wavelength. So basically an intense blue light, but it's pretty specific right around that range without too
Okay.
much variation, which is sort of critical for autofluorescence. So if you're looking at sedimentary rocks, like things like corundums will like fluoresce like bright reds, or calcites will start to fluoresce greens, and
Okay.
things like that. Yep. But in order to actually observe the fluorescence, that's where the yellow filters come into play. So what you may have just seen is actually just the blue light illuminating the subject matter, but you're not actually able to visualize the fluorescence yet until you add the yellow filter. So what you'll do
Okay.
is you'll add the yellow filter to the front of the lens. So there's a 58 millimeter, and then
Yep.
there's a 77 millimeter. The 77
Yes.
millimeter is to put in between the objective and the telephoto lens in order to correct the light coming in through the micro kit. And then the 58
Okay.
millimeter is to correct the light coming back in through the MPE 65, 1 to 5x.
Okay.
So what happens is that yellow cancels out blue. So what'll happen is you're emitting all this blue light at 505 onto your sample. But so here you can see like the Earth in the Macroscopic Solutions logo is blue. But if I actually maybe if I do this, I filter out
Yeah.
the light. What happens is that the blue actually disappears. It completely filters out blue light. So what you're left with is the fluorescing materials that are on the sample. So what you'll do is you'll then begin to observe those fluorescent colors. Does that make
Okay.
sense? Yeah.
Like we did get pink specks throughout the rock, though. So
Yep.
is that fluorescing as well?
You did use the yellow filter, right, to
We
correct?
did not use the yellow filter.
Yeah. So no, you probably it's probably not correct. Yeah. So that
Okay.
probably I think all you were doing is casting a blue light over your material, and the camera was identifying blue reflections of that sample, but you wouldn't
Okay.
observe fluorescent material until you correct it with the yellow filter.
Okay.
Yeah,
Yeah. Like, and I think there was mica or something that sampled that was very shiny, so that could have been it as well.
definitely. Yeah, because the mica is going to reflect the light right back into the camera. I don't believe mica is fluorescent material though.
Okay.
That might just appear black after you correct it. Um, it would be very specific, but I do believe that bone material, the calcite in bone material, will fluoresce probably green.
Okay. Like
Hmm.
what I wanted to try it is with fox squirrels that have a genetic mutation thing that makes it so they can't process a protein, and then
Oh,
that goes into their bones, and then that protein fluoresces pink in a UV light. So do you think
oh.
that would probably work?
Um, I cannot say for sure. I'm not exactly sure of the wavelength that's going to be excited there.
Okay.
I will say that many of the properties, like when I just go out in nature with a UV light, many of the fluorescent like lights that I would see sort of shine back are very similar to the types of autofluorescence that you would see with this kit. So I think you might
Okay.
actually see it. Yeah, it's very
And
possible.
it's something I can try at least to see what
Yeah,
happens.
absolutely. If you want to confirm you have your filters set up correctly, I'd actually advise to like you have a plant right behind you. If you took just a piece of the plant material, what
Okay.
happens is chlorophyll will fluoresce bright red. So the
Oh,
chlorophyll
okay.
that's in the cell structure there, you'll know that the kit is working properly if you observe red.
Okay. So
Mhm.
just if and you would put the filters over the flash and then put the yellow filter on the lens, and then you should be able to image it and you should see red fluorescence on a plant and everything else would be black then?
Yes. I mean, there are going to be there could be other materials that do autofluoresce at different
Okay.
properties.
Yeah.
Yeah,
But
so I can
like you
actually,
shouldn't see the blue as much. The blue should be filtered to
yeah,
blackish color.
yeah. So you should see zero blue. Blue
Okay.
should disappear entirely. What I'll do is I'll share my screen. I'll kind of give you an idea of what you will be seeing.
Okay. And
Um,
I did find the image that I had that I can share with you so you can
oh
see
yeah, that'd be
what I
awesome.
got.
Yeah, do you want to share your image first?
Sure, if I
Okay.
can figure out how to move it. There, okay.
Ye-
Let's see. Do I have permission to share
Oh
screen?
yeah,
Can
I
you
was looking.
give me
There it is.
permission?
Found it. There you go. You should have it now.
Okay, here, share. So, think you can
Okay.
see the blue image.
Oh yeah, yeah, absolutely.
And then there's like these pink things throughout it. So that's where
Oh,
like,
okay.
are those different mineral fluorescent or something like that one? And that one's really shiny, which this is what it looks like without the filter. So it's those specks.
Interesting. Yeah, so I think it is very likely that that is what you're seeing. You're seeing autofluorescence of material that's coming out very intensely red and
Okay,
and it's just the problem is it's a little bit hard to visualize because the blue is not being filtered out yet. But
okay.
it will become much clearer when the blue is filtered out.
Okay, so if you put the yellow on, this would be more grayish black colors probably, and then you would see like, oh, these are red speckles that kind of shine through.
Yeah, I'm trying to think too if once you correct pink with yellow, what color you get. My suspicion is that is likely calcite in a sample like that one,
Okay,
which means it should appear a little bit more green.
okay.
It's interesting that it's green in the plain light photo. There's little
Yeah,
green.
like this one's greenish, other ones are kind of just whitish.
Yeah, the white ones I would say almost are like calcite, but you might actually have something like a little emerald in there. Um,
Okay,
that's possible.
yeah,
Yeah, yeah.
yeah.
Um,
So did this like, oh, that's cool. How can I use this for other things? So,
Absolutely. Yeah, you should be able to. Yeah, so what I'll do is I'll show you a kind of a collection of some things with the fluorescence kit here.
okay.
Uh, and then it'll kind of give you an idea of what you'll be seeing. So can you see my screen okay?
It says you're screen sharing, but nothing is, okay, now I
Oh,
can.
perfect.
Yeah,
Got it. Okay. So what I'll do is I'll go to albums and we'll start in the rocks and minerals section just so that we're kind of on the same page. Should be, I guess petrology is where I had it. Nope. Just be a mineralogy. Oh yeah, mineralogy. Here we go. And move. Fluorescence kit was kind of introduced a little bit later, and these are in chronological order. So let me see if I can find the end of the album. Should be getting closer. Yeah, so this is an example of fluorescence. So this is plain light, and what you're seeing is calcite in between, like a I think probably like a chert, some sort of a silica-based mineral.
okay.
It could actually, and then this is the result. So you can see that the calcite is all fluorescing really green, and then you get these orange hot spots, which could just be some other fluorescent material. Could actually be dust. Dust is actually highly fluorescent as well.
Oh, okay.
Yep. And then like here, this is a good example of it's a ruby, not a very great sample, but so you know, you probably call it corundum. Well, you know, just because it's not actually like a pure red. And then there's
Okay.
also calcite intermixed in between this sample, and you can see the calcite is a green speckle, and then the corundum is fluorescing this bright red color. So that's kind of what you would see. And then some examples in other tissues. So what I'll do is I'll show you plants really quickly. So these are pine needles, and all of these were imaged in fluorescence. So you can visualize the cells, and sometimes if the pine needle is dead, the chlorophyll will start to leave the plant matter. So you'll no longer see it.
Okay.
But the individual cuticles here are fluorescing purple, and
Yeah.
then all of the actual chlorophyll or chloroplasts are basically fluorescing red.
Okay.
Yep. And one other example, kind of more on par with skeletal structures. So this is like a little mammal album. These are cleared and stained specimens at the top. However, this is a mouse embryo that has been stained with GFP for in order to achieve autofluorescence in the blood of this. So
Okay.
basically, what we're trying to do is visualize the circulatory system. So the blood is actually here fluorescing bright green, and that allows you to make those observations as well. So
Okay.
the kit should be able to do those types of things. Gets a little
Okay.
bit trickier when you're at high magnification, but you can see here, these are individual blood cells. You can even see the
Oh,
torus shapes in them,
okay.
but you can see it's still very possible.
Now, do you have any examples with insects? Because I work with insects, so
Yeah, I think let me see here. I think let me just make sure that I think I just stopped sharing. Let me reshare.
yes,
Uh
you did.
yeah, okay. I think I have some examples of insects. So the thing is that some insects are fluorescent, and then what I find is actually most insects are not, though.
Yes, that's
Um,
where, like, to my knowledge, there's not too many, but there's a lot that have UV reflection. So it's like, how closely do those overlap is what I'm curious about.
yeah, I think oh wait, oh no, this is the only example. We did a fruit fly eye, and again,
Okay.
but the eye. So there are some. I found that the eyes of leps sometimes autofluoresce. The eye of this fruit fly has been stained with GFP as well, so it's been
Okay.
genetically mutated. Um, so that was induced. But I think that, as far as I know, that's the only other that aside from this tapeworm, that's the only other invertebrate that we've actually used fluorescence on.
Okay.
Yeah. So not too
Is
many
it
examples.
okay? That's kind of what I thought. I'm like, maybe you're like, oh, these ones generally do it. So
Yeah. It'd be neat. I don't think a lot of people have tested like every insect though. So it might
yeah,
actually be neat. You might actually discover a sample that could autofluoresce, which would be very cool.
and I believe millipedes do, but I've heard they're really hard to image because it's a very faint fluorescence. So yeah.
Yeah, maybe give a millipede a shot first. I've heard that as well. That might actually be a really neat target specimen.
Okay.
Yeah.
And you said that's 505 nanometer wavelength?
505. Yep.
Okay.
Right around that range. The only other sort of tips that I'll give you is that when you do mount these onto your flash, it's really important here because what happens, because you're only emitting at 505, you're canceling out all of that other white light, which means that you really need to get light closer to the source. So
Okay.
the lighting intensity is diminished by quite a bit, by 90%. So you
Okay.
might have
That
to
makes
increase
sense.
the flash output. Like, don't go too high because um, you don't want to overheat. The other thing is too is because you're blocking so much light, the byproduct of that is actually heat. So these will actually start to heat up. So you kind of want to
Okay.
stay in a range of like maybe 1/4, 1/8, and then maybe compensate the rest of the brightness using the ISO and the camera.
Okay.
Another way to kind of change that is rather than having the flashes where they normally lie on the Macropod, just kind of lift them up and get them really close to the sample. Like they can literally be like inches away. But these,
Okay.
like white light, you don't need to diffuse the light. These need to be shined directly at the source.
Okay.
Yeah.
That's good to know.
Yeah. Yeah.
Hmm. So I think that answers my questions for that. Then I guess, can you tell me about the petrographic analyzer since I had them
Oh, yeah.
confused? So,
Absolutely. Yeah. So the Petrographic analyzer, I think I almost certainly have one here. Give me a second. Um, I do with the analyzer. I know I have one somewhere. Here might be at my other office. Oh, okay. This'll do. So basically, here's one that's kind of half built. So this is for geological observation. And what it is, so they come in different shells. So there's some that are made for the Yongnuo flash. There's some that are made for the MT24, the
Okay.
MT26, and now the Godox flash. So that's the new flashes that we're using with the system. They're wireless,
Okay.
which is actually
Oh,
nice
that
because you
sounds
can
nice.
mount these in here and then the wires don't tug on the analyzer.
Yeah.
Yep. So what this does is it functions like a petrographic microscope. So on
Okay.
here is a UV filter, and the UV filter sort of acts as a base. So it's basically the stage of the microscope. And then, actually, no, sorry, the polarizer is the fixed, the fixed filter at the bottom. We rotate them around, and then the
Okay. Yeah.
UV is the one on the top. So what'll happen is if you place a slide or a thin section with a geological sample, what you can do is you can actually observe all of the minerals in thin section in plain light. But because minerals have very distinctive and unique optical properties when you cross polarize the light, what you can do is take another polarizer, the same way as we did the yellow filter, and mount that on the front of the camera lens. And then you
Okay.
turn it so that it's at 90 degrees to the orientation of the polarizer that's down here. And when you do that, what it does is it blocks 100% of the light that's passing through to the camera. So everything goes black. But
Okay. Yeah.
when you place a slide that has minerals on it onto this analyzer where you cross polarize, what will happen is the minerals, like the actual mineral structure, like the atomic structure in the minerals, will basically reproject light coming out at a different angle, and it produces a distinct
Okay.
color. And every mineral is actually completely unique from the next. So it's a very diagnostic feature to identify mineral composition within different rock types.
Okay. And
Yep,
with that, basically the minerals are unperpendicular in your polarization, you could say.
exactly. Yep, that's
Okay.
exactly right. Yeah. And what's neat is that the analyzer itself isn't just for geological slides in thin sections. You can place a regular slide on here. And what's really nice is, unlike a microscope where the light source is at the bottom, it's very intense. You get some very, very bright light around the edges of your sample. Whereas here, we're actually kind of diffusing the light again because we're projecting it down. We're illuminating something
Okay.
soft
Yeah.
on the bottom. Yeah, and that reprojects up. And then what's neat, like doubly neat, is that if you're looking at any slide under a microscope, you can't see the label data because it just appears black. But if you add the diffuser to the front of the lens, that diffuser will help bounce the light back down, and then you actually can visualize the
Okay.
label data as well. So
Okay. Yeah.
yeah, and I'll show you some examples of this as well. Share. So what I'm going to do is, so I'll go back to the mineralogy album. And I'll show you some examples of what a slide looks like in plain light, and then when you add your second polarizer. So all of these are actually slides. I'll find like a good example
No.
though.
Okay.
Yeah, so this is actually this is a good example. So this is a projected light. Actually no, this is, I think we inversed the images, the color on that one. I think. Oh yeah, that's because it's a blue. That's right. It's so there's a blue mixture because this is just sediments. So it's been basically set in a blue resin and then sliced in order to fix them. But
Okay.
you can see here we can read the label because we're getting basically a combination of transmitted and reflected light, which is pretty unique. And then we're imaging the entire slide and all the minerals. But then what'll happen when you polarize this sample is all of those minerals will then reveal its optical properties. So you can see all the light coming through the slide is now black,
Yeah.
and all of the sediments in here are now basically showing their cross Nichols characteristics.
Oh. Okay.
And there's let's see, there's this sample here. This is just basically zircons that are set on a glass slide at high magnification to look at the inclusions for age dating. So those are still this is what it looks like at a lower magnification.
Okay. Yep.
And then again, another sort of another example. This is actually this is the best example. This is the one I was looking for. So this is what's really neat about this type of system is that when you shine light from a microscope, what I was talking about is how the grain boundaries appear really bright. See how the grains here are very bright, like all the cracks. You can see the
Yep.
light is so intense, it's coming up through the minerals. But what happens when you use our analyzer is that those, because we're reflecting the light, now the grain boundaries are actually really matte and uniform. So you get this beautiful image without light sort of covering up the optical properties of the different minerals. This is a plagioclase grain, and then some quartz, and then some possibly some olivine or something like that that's in here. It's actually been a while since I've taken a course, but that's essentially what this product is doing.
Oh, okay.
Yeah. Yep. So I don't know that, did you guys have the Petrographic analyzer? I
I
don't think.
don't think we do, but maybe you said we could get it, and that's where I got confused.
Absolutely. Yeah, I think I know that who was the other gentleman that I was talking with that was there?
There
Um,
was Andy Kozlowski and I think Carl Backus.
that's
They were
right.
they're the sediment core people who were interested in something, so
That's
probably
right.
talk to them.
Yeah, yeah, I think that they wanted to add a few of the geology capabilities. So that's one of them. And the petrographic analyzer actually fits onto the core scanner. So if you get a core scan, the petrographic analyzer will go
Yeah.
on, or it'll also automatically scan your slides.
Oh, okay.
Yeah, so they're kind of they're separate products to sort of like make it less expensive. But if a
Yes.
core scanner was implemented as well, which would actually still be pretty low cost because you have all the other gear,
Yeah.
um, then basically you just combine them and then you use them both. It functions as a core scanner and a petrographic microscope.
Okay.
Yeah, very
So
cool.
yeah.
Yeah. So has anything else like come up as you've been using this system, or has it been working okay for you? And
Yeah, it's been working
yeah,
okay when people ask me to reconfigure the mounting stage. I always have to like think a little like how do I do this?
yeah.
Going from the insect mounting to larger things. And this is the first time where we had to do vertical mount because they're large rocks.
Oh yeah, yeah.
So as I was
Gypsum
taking
will do
apart,
that.
it's like all these pieces go together, but I couldn't figure it out. And then it turned out had a piece in the bag still. And it's like, oh, that makes this all make sense.
Oh,
So
definitely.
yeah,
Good, good. Okay. Yeah, if
but yeah,
anything comes up, feel free to reach out. I'll give you a hand on it.
yeah, like I don't think anything else unusual has
Hmm.
come up. So yeah,
Okay. Terrific. All right, well,
so
it's
yeah,
been great. It's been great touching base. And yeah,
yes,
let me
and
know how the fluorescent imaging goes.
yeah, like hopefully we can get some glowing purple or glowing pink squirrel bones. That would be
Yeah,
fun.
yeah. I think that'd be
So
pretty cool. Yeah.
yeah,
Awesome. Cool.
so yeah. Well, thank you for your information, and I guess
Absolutely.
have a good rest of your day then.
You too. Thank you, Ryan.
Yep.
Take care.
Bye.
Bye.